Hi everybody, this is my Lab 5 report. In this investigation, I model a collision between two carts where one cart slides down a ramp with friction before colliding elastically with a second cart on the ground. My goal is to combine video-style physics analysis with GlowScript modeling to understand how friction affects momentum. Here's the structure of my presentation. I start with the physical system and assumptions, then walk through the physics model in GlowScript code and show the results, and finally answer several what-if questions. The purpose of this project was to investigate how friction on a slope changes the speed and momentum of a cart before a collision. I used GlowScript to simulate the motion, calculate the energy and momentum in real time, and observe how non-conservative forces reduce the energy available at impact. The key ideas here are Newton's second law, energy, momentum conservation, and kinetic friction on an incline. Before the collision, friction removes mechanical energy, but during the collision itself, we treat it as a perfectly elastic, so momentum is conserved along the x direction. The system consists of two carts. Cart 2 begins at rest on the slope and cart 1 waits on the flat ground. Friction only acts while cart 2 is on the ramp. After it reaches the bottom, the motion becomes 1D. The collision is modeled as perfectly elastic. The motion on the slope is computed using the standard Euler method. The downside acceleration is gravity minus friction. This already shows that friction reduces the final speed significantly. When the carts overlap, I apply the standard elastic collision equations. Momentum and kinetic energy are conserved during this instant because friction does not act during the collision itself. This is a screenshot of the scene in the results. This is the code for the initial setup to set up the geometry, initial conditions, and parameters like friction, masses, and the angle. This is the heart of the program, which is the time loop. It first checks if cart 2 is still on the slope, updates the acceleration accordingly, and then switches cart 2 to horizontal motion once it touches the ground. This part handles collision detection and applies the elastic collision velocity updates. The condition ensures that the collision only happens once. This is a visualization of the result. Cart 2 accelerates on the ramp and reaches the ground with reduced speed due to the friction, and then collides with cart 1. This is the energy graph showing the total mechanical energy decreasing while cart 2 is on the slope. Once it reaches the ground, the potential energy becomes 0 and only kinetic energy remains. After the collision, the kinetic energy is redistributed between the two carts. The momentum plot shows the total momentum increasing as cart 2 accelerates. At the collision moment, momentum is conserved. Afterwards, momentum is split between the cart 1 and cart 2 based on the elastic collision equations. In reality, friction is not constant. Collisions aren't perfectly elastic, and the carts would rotate slightly. All of these simplify the model but make the simulation easier to analyze. And these are some of the sources of error, including that the real friction would vary with the speed and there's no air drag, and other things that vary from a realistic standpoint. I also explored a few what-if scenarios to understand how different assumptions affect the outcome. Small parameter changes like reducing the friction or increasing slope angle dramatically change the collision speed. To conclude, friction on the slope plays the largest role in reducing cart 2's kinetic energy before impact. The collision itself behaves exactly as predicted by the momentum conservation. Overall, the simulation aligns well with the physical expectations.